Estop is the most failed item on a control safety inspection. New programmers wire it as a single-channel input to a regular PLC and assume the rest. That assumption fails inspections, fails audits, and most importantly puts operators at risk. This video covers what the estop PLC wiring actually needs to be. The stop categories from IEC 60204-1. Dual-channel monitoring. Safety relays versus safety PLCs. Reset logic. And how to integrate the safety circuit into a regular PLC for visualization without compromising the safety boundary. IEC 60204-1 defines 3 stop categories. Category 0 is uncontrolled stop. Power removed immediately. Motors coast to stop or are mechanically braked. Category 1 is controlled stop. Power maintained briefly while the machine decelerates under control, then power removed. This is what most machines with rotating tools or large motion need. Category 2 is controlled stop with power maintained. The motors stop under control, but power stays on the drives. Used on small machines without stored energy. The category needed depends on the risk assessment for the specific machine. Pick the wrong category, fail the audit. Dual-channel monitoring is the rule for Category 3 or higher per ISO 13849. 2 independent channels physically broken by the same estop button. The button itself has 2 sets of contacts wired in. A safety relay or safety PLC monitors both channels for agreement. If one channel sticks closed while the other opens, the safety device detects the discrepancy and forces a safe state regardless. Single-channel estops where a single contact removes power are not acceptable on Category 3 machines. Full stop. Not negotiable. Not down to opinion. The wiring uses a 4-pole mushroom button with 2 normally closed contact pairs. The safety relay versus safety PLC choice depends on complexity. Safety relays are discrete devices. PLCs, Banner, SICK, Omron G9SP. One safety relay monitors one estop circuit plus a couple of safety gates. They are cheap, reliable, and require no programming. The wiring is the program. A safety relay is the right answer for a single station machine with one estop and a guard door. Safety PLCs are full programmable controllers running certified safety code. Allen Bradley guard logics. Siemens safety. B and R safety. These are required when the safety logic gets complex. Light curtain timing. Multiple safety zones. Muting. Presence sensing safety. Anything that would require a wall of safety relays is a safety PLC's job. The standard wiring pattern. From the estop button, 2 channels of normally closed contacts. Both channels go to the safety relay or safety PLC inputs. The safety device's safe state outputs feed contactors that physically interrupt the motor power supply. The contactor coils are wired through the safety output, not the regular PLC. When the safety device is in run mode, the contactors are energized and motor power is available. When the safety device trips, the contactors drop and motor power is removed at the contact level. The PLC's logic cannot override this. That is the entire point. Reset logic. After an estop trip, ISO 13849 requires deliberate manual reset, not auto reset on estop release. A separate physical reset button. The standard rung pattern uses a one-shot on the reset button input to enable the safety contactors. The condition for the safety device to come out of trip state is the estop must be released. The reset button must be pressed deliberately, then released. Then the safety device transitions to ready. Auto-resetting on estop release is a common shortcut that fails audits. The deliberate reset is there so the operator cannot accidentally re-energize a machine just by twisting the mushroom back up. The regular PLC reads the safety circuit status for visualization only. The safety relay has auxiliary outputs that report its current state. Wire those auxiliary outputs to regular PLC inputs. In ladder, read the estop status as a contact and drive an HMI indicator or a status bit. Never trust the regular PLC's logic with safety-critical decisions. If the regular PLC's program decides the estop is fine, it does not matter. The hardware safety device makes that decision independently. The PLC's view is for the operator screen and the historian. The safety boundary stays in hardware. Practice the rung pattern at plcsimulationsoftware.com. The free tier includes the safety-aware motor starter pattern that integrates an estop input into the ladder for visualization. The simulator does not run certified safety code, but it does let you build the integration logic before touching real hardware. Next video covers a day in the life of a controls technician. What the actual work looks like across a typical week. Subscribe, new video every Tuesday. See you in the next one.